Hi, everyone. Good afternoon. I'm super excited to be here. This is my third time at Shift, and it's always good to come back here. Today, I'm going to be talking about how to build autonomous AI agents that can run anywhere. Like he mentioned, my name is Egwuenu. I work as a senior developer advocate at Cloudflare. And with me here today, I am with my baby. She's at the back, baby Zuri. This is her first conference, so please, a round of applause for her. So let's get right into the talk. Who here is hearing about AI agents for the first time? Hands? I assumed like everybody here already knows about AI agents. So yeah, you all have probably heard of AI agents. I mean, who am I kidding? It's literally a buzzword right now. We now live in a world where you can ask an agent to, for example, plan a trip end to end, your flight, your hotel itinerary. Basically, I do this where if I'm going somewhere, I don't have to think about, oh, what should I do? For example, we're coming to Zada, what should I do? I literally use AI for that now. And the great thing with AI agents is sometimes it doesn't even require human intervention, right? You can ask an agent to do things for you without manually or having to, ask them or prompt it to do anything extra. Let's take a look at this image for example. This is showing the two different types of AI, agentic AI and generative AI. The core difference between both of them, as you can see, is on the, I'll say my left, we have agentic AI. And basically what I'm asking it to do is to run a campaign following up with everyone that I've met at a conference. You can see it's going to go ahead and, for example, get a list of all the customers that I met. It's going to draft up an email. It's going to send to me a sign-off, and it just goes and does everything end to end. So from beginning of the workflow to the end, without me even asking it for any extra thing. On the other hand, you have generative AI, which we are mostly familiar with. This is your typical LLM, ChatGPT, and so on. The difference here is with generative AI, you as a human still need to review or, for example, when you get the list of customers, you still need to add your own manual input in there. So that's the core difference with generative AI versus agentic AI. Agentic AI basically allows you to, build autonomous agents that can go on and do things for you without you adding anything into it. So basically, that's what agent is. An AI agent is an AI system that can autonomously execute tasks by making sure decisions about tools and usage have literally gone through like a process flow. The good thing that I will highlight in my talk is sometimes, like I said, agents don't need manual input, but there's something called human in the loop where, it could be important to also add your human input to the agent, which we'll cover as we go on in this talk. So let's talk about the rise of AI agents. I'm going to share 3 distinct examples. The first one being a traditional automation system. With traditional automation system, you literally first have to enter an input. Maybe you're trying to book, for example, a trip. I'm going to use Trip Planner as my example throughout this talk because at the end, we'll be building a travel AI agent. So let's say, for example, I'm trying to book a trip. With a manual automation system, I literally have to go in, add the date of my trip, the location that I want to go to, if I have a budget, before I can get an output, right? However, if something changes, I still need to go back one step. So for example, if I figure that, I'm trying to go to Dubai and it's a bit too expensive, I have to go back one step and, manually change things. And that's your traditional automation system. You still have, or you still need human input in the flow. On the other hand, AI Copilot is also a different way of automating things with AI right now. Your typical AI Copilot acts as an intelligent assistant that can provide you with context, so you can ask it, for example, how you would prompt ChatGPT to give you an itinerary because you're going to Zada, for example. This would go through first asking for an input, then it will probably use one of the open LLMs out there as a model to get a response. And then you still need human input here. For example, if you need to go on and book a flight based on the recommendation the LLM has given you, you still need to do that yourself. And finally, you get like action, which is basically you booking the trip. And this is where AI agents shine, right? An agent combines the ability of the two different process flows that I just showed you to make judgments with autonomy for you. So the step that I initially outlined, which is you put an input, you ask LLM to help you generate, for example, itineraries for a trip. But then you are also adding something called tool, like an MCP tool in this case. This would basically automate some of the flows for you. For example, with MCP right now, you can use flight booking API to then go on to book the flight, so you don't have to do it yourself. So this is a typical process for an AI agent. In between the prompts that you're asking your LLM, you can also add tools to help you take out the manual tasks that you typically have to do yourself. Now, this is all nice. Even with all the promise that AI agents has, there are still some hard parts of building agents, which we'll cover in this talk. The first one being identity, right? What is making the request? So when you're building an AI agent, you want to be able to connect it to external tools and services using an MCP, right? But how do you actually do that? That's the core part of identity. We need to be able to authenticate and authorize to external services and tools. We'll cover how to do that. Another aspect of the hard part is memory. How do you maintain states in your AI agent? We'll also talk about that. And finally, coordination. How does an agent coordinate tasks and manage resources efficiently? But the good thing is there's a solution for all of this, which I'm going to be sharing in this talk. So introducing the platform for building agents, Cloudflare agents. If you missed it at the beginning, I work at Cloudflare, so you hear a bit of Cloudflare in my talk. But this is where Cloudflare agent comes in. It provides a foundation for building intelligent, stateful agents that persist, that thinks, and evolves on Cloudflare developer platform. And the most interesting thing is it's very easy to get started with. You basically run npm install agents, and you have the agent SDK in your application. So let's talk about the agent SDK. The SDK comes pre-built with so many features that you would typically need when you're building an AI agent. First, we have something called MCP agent. This is what allows you to host remote MCP servers with OAuth support, the transport, either you're using SSC and HTTP streaming built in. You also have built-in state management with durable objects. You have real-time WebSocket connection, and this agent SDK uses React. So if you're a React developer, this might find this interesting. We have a use agent tool that uses built hooks for the implementation with React, and also basic AI chat capabilities already installed in the SDK, so you can just get started. But what makes up an agent? So in this talk, I am going to be outlining 4 different parts that makes up an agent. Of course, this could be different for like different people, but this is how I like to see it. So first, we have the client, then we have AI, we have workflows, and then we have tools. So let's talk about these 4 things using the architecture here. Like I said, I'm going to be talking about building a flight travel planner MCP. So that's the example I have. That's my baby. But it's OK. So here I have a travel agent that I would build in this talk. And in my agent, I have different tools. So I have a tool for booking flights, one for finding hotels, one for checking my budget, and of course, you can extend this more than what we have here. And on the other side, you have something called user feedback. I mentioned that with AI agents, sometimes you don't need human input. You can basically ask an agent to go and do something for you, and it does it right. But sometimes you still need to ask or approve before an AI agent, for example, has access to your bank account. You don't want that, right? So I'll talk about human in the loop on that part. But with AI agents, you follow different steps. First, you ask or you send an instruction, and then it prompts it using an LLM, which is the interpretation and reasoning part. And then I'll talk about workflows in my talk. So going from user instructions to interpretation, workflow generation, and then to the outputs that you expect to get. Let's look at this diagram. So this is how I would typically build a travel planner agent. First, I would, as a user, try to, of course, use the travel planner. I need a chat UI. So if you right now are trying to interact with an agent, it's usually with a chat box, but also recently there's also voice, meaning that you can speak to an agent and get the response back. So this could either be chat UI or voice. Then I would use something called Cloudflare Workers AI to get models that I'll be prompting. I could either use Workers models or models from Cloudflare Workers or use from OpenAI. It really doesn't matter. So you can swap that part out with any LLMs that you're going to be using. And the workflow part is basically where you kind of integrate the different parts of your application within the workflow. So what's a workflow? In this term, a workflow is basically what you want your agent to do. So it goes from, for example, if you want to book a flight, it goes from finding the flight for you to finding the hotel for you. That's a different workflow. And when it gets time to book the trip, you can then ask it or approve the trip before then going to book it. So in the diagram above, before this, I had tools. What are tools in the concept of AI agents? Tools are something I would like to call MCP, which I'm sure a lot of you are familiar with. The MCP is an open standard that allows you to connect AI systems with external tools and applications that gives your agent even more power than it usually would have before. I really love this analogy of an MCP. You can think of an MCP as a USB port. It basically allows you to connect different tools, right? So you have different concepts in MCP. You have the MCP host, which could be Claude or ChatGPT or Cursor. I mean, there are so many MCP hosts out there right now. You also would need MCP servers. So you can think of, in my example, I'm building a travel agent MCP planner, and I would like to connect to some travel APIs, for example, booking.com for booking hotel, Amandus for getting flight information. So with an MCP server, you connect to different tools, external tools. You can even use local files within your computer as an MCP server as well. So these core concepts, the MCP server, MCP hosts, are very important as we move ahead in this talk. So when you build an MCP server on Cloudflare, you extend something called the MCP agent class, which I showed earlier. This class is gotten from the agent SDK, and it means that for every instance of your MCP server, it has its own durable state. It has a SQLite database that is built, backed by durable objects. And with this, you have your own SQL database. This is very important as we move ahead in this talk. So now let's see how to solve the initial challenges that I posed. So I spoke about identity, I spoke about memory, and how you orchestrate your application. So first, to solve for identity, you need to know who is making the request in your agent. And for that, Cloudflare has a library called Workers OAuth Provider. This essentially allows you to build authentication into your MCP server. You can either use, for example, Google Auth. You can use Auth0. I mean, there are different OAuth providers out there, and it's connected to the library, so you use it within your application. This is an example code showing you how you would typically use an MCP, a third-party MCP server in your Cloudflare worker. So the most important line here is the default handler, where you add the handler from the MCP, from the authentication client that you're using. So with the auth provider, we have different implementations available. We have with GitHub, we have with Auth0, we have with WorkOS. The most important part when building an agent is when you want to have authentication and authorization built in, you need to look at this. I don't know how visible this diagram is, but it basically follows different flows. So first of all, your user logs in to your client. So it could be maybe an MCP server that you've built and you've connected to Claude. Once the user logs in, they get redirected to the identity provider of choice. Let's use Auth0 as an example. So when the user logs in, they get redirected to the identity provider. The MCP server then exchange a code that the identity provider is generating, so an access token that I would call, in this case, a bound MCP token. Once the MCP server issues this token, the next step is it transfers it to the MCP client that then uses this tool or uses the code to call the tools that already exist within the MCP server. So this ensures that every action within your agent is tied to an authenticated user, making sure that nobody that is non-authorized to make a request can make that request. This is also very nice because you can add authenticated contexts like your user information. So for example, if you have an MCP server and you want, when a user logs in through one of these IDPs, you want the user to have, the user's information like their username, their email address, so that you can use it within your agent. That's also possible. So the next challenge that I posed is memory. How do you remember context across your sessions with your agent? Because without memory, every request is fresh. So if you have to talk to an MCP or an AI agent without any context, you literally have to do the same request over and over again. But how do we actually remember across sessions? So first, Cloudflare have something called state management capabilities within every agent in the agent SDK. So every agent has built-in states, and it's backed by Cloudflare durable object, like I mentioned. It helps you basically synchronize your connections between the agent SDK and your front-end application. These are some of the core things that it ships with. It has it's persistent across agent restarts. It has auto-serialization and deserialization, and it's immediately consistent across reads and writes. And finally, it's super fast. I'll show you a demo of how this works in a bit. But whenever you're building state management into your MCP, you have, by default, an initial state class, and then just similar how you manage states with React, actually. You can set states, you can use the states in another context within your agent, and so on and so forth. This is an example book MCP server that I built. And here I want to persist the state of the books that is being added, or the genres that is being added within the MCP tool. So you can see here that I've defined an initial state for my favorite genres of my book. And when I then initialize it to, so I have a tool here called add genres. So it adds a genre for different types of books. And then towards the end of the code block, you see that I'm updating the state so that the state is persisted within that MCP tool. So that's how we solve for memory, right? This would make more sense when I show you a demo, but with durable objects, you have states persisted within your agent. Finally, coordination. This is the last part of the challenge that I want to share, and how you can actually solve it. So how do agents coordinate tasks and manage resources efficiently? The MCP agent, or the MCP SDK, also ships with hibernation by default. What does this mean? This means that whenever you're running resources, and probably it's idle for a little bit or maybe a long time, automatically it's shut down for the time that it's not being used, right? So MCP instances automatically support WebSocket hibernation, allowing your stateful MCP servers to sleep when it's idle and then restart when the process is started again. This is the diagram that I showed earlier from my travel agent MCP, and I went ahead to build this. So I'm going to quickly show you a demo of how it works in action. So let's see here. By the way, we also have an MCP agent starter kit, and this ships with all the features that I mentioned, stateful connections. The use agent chat is already installed within the application. It uses React, so you have your chat application built. So what I built is a travel agent MCP server, right? So I would increase this because I feel like it's too small. I ran this prompt like a little earlier today. I asked it to create a 5-day Croatia itinerary just to test how state is persisted between the sessions in this MCP. I'm going to go ahead and restart my server. So npm start. And then I'll open it, and we should still see the previous conversation that I had earlier this morning persisted. This is all working with the durable objects function, this.setState that we have within this application. So what do I have here? I'm just going to restart my chart here. Like I said, this is a simple AI travel planner that I've built, and it connects to different tools, which I'll show you. It connects to an API called Amandus. It basically gives you flight data. It gives you hotel information in a specific city. So for a try, I'm going to try one of this. I'm feeling lucky buttons that I created. So I'm asking it to search flights in Amsterdam to Lisbon, leaving in October 8th and returning. And I've set a budget of $800 for one passenger. So let's see what happens and see the result of that. So what's happening here is I have a few arguments. So basically the request that I've sent, and then it's going to send it to the API that I've implemented in the flight search tool, and we see a few suggestions here. It's also asking me if I would like to proceed with booking of one of these flights, and I would say yes. I would book the one with, let me just specify the price, $365. And then it triggers another tool that I have, which is book flights. So before proceeding, okay, it's asking me to confirm the details about the flight, and it also wants my name. So I'll just give it Jane Doe. So this is another tool within my AI agent called Book Flight. This is essentially going to mock the booking of the flight because I'm not actually going to book this flight. And what I see here is I get a prompt asking me to approve or reject it. So I spoke about human in the loop earlier, where sometimes with an agent, you probably don't want it to go ahead and do every single thing. Maybe you want it to have, like, for example, a prompt to ask you if you want to actually proceed with that information. And this is how you set it up. In the code, I'll show you how it looks like. But then I'll go ahead and approve this request, and my flight from Amsterdam to Lisbon will be successfully booked. So that's a simple example showing you how to book flights. So let's look at the code. I'll go ahead and increase this a bit. Yeah. So I have, within the Cloudflare agent demo that I've made, this is using the agent starter kit. I have here a server.cs file. So within the servers.cs file, this is using the AI agent chat agent, and it basically has the most important part here is this export class chat extend AI agent. This is where I'm setting up my LLM of choice here. I'm using OpenAI. And then I'm also calling all the tools. So for this specific application, I have several different tools. I mentioned that tools are essentially what gives your agent context and power by connecting to external sources and tools. So for this, I have a few tools here. I have a search fly tool. I can hardly see my screen. But I'll show you one example of a tool that I've built. So this tool is basically what searches for flights. Here I have set up some type checks, and within this service called Service Search Flight, let me just open it. This is what connects to the API that I'm using. So I'm using an API from Amandus, and I have basically passed in all the important parameters that I would like to get from the API, and then I'm setting a bearer token because the API requires me to have that before sending the request. So within the tools file here, this is where you define the core part of your agent. So if you want your agent to be able to, for example, book a trip for you and add the hotels as well, which I have done for this application, this is where you set that up. Another nice feature that the agent SDK has is something called scheduling. So for example, you can ask your agent to remind you of something, and it goes ahead and does that for you, and it uses something called, well, this is currently the unstable version, but it uses something called schedule schema, and then reminds you of the specific reminder that you set. To try this out in my agent here, I am going to ask it to remind me about my lunch in 20 seconds. So it's going to schedule the task and schedule the reminder for lunch in 20 seconds. And even if I close down this window that I have and open it up in another browser, I would still get the reminder. Why? Because the state is persisted across different sessions. So it's running the scheduled task, and here it's returned my reminder in 20 seconds. What else do we have here? So this agent SDK has the server part, but also the client is using the UseChat library, which we've built and extended that you can use within your React application to build out the UI that you see here. So what is powering the chats, what is powering the set states is all within the AI agent SDK UI library. Yeah, so going back to my diagram that I have here, I've showed you basically first the client, which is the chat UI that uses the agent SDK, and then I'm connecting it to an LLM. For my case, I'm using an LLM from OpenAI, which I have here. Let's see, yeah. I'm using a model from OpenAI, and this workflows part is considered important in my case because in my implementation, I wanted to have a point where I, as a user, can actually approve or reject. So this is where I'm putting the workflow for human in the loop, where in the process of the workflow, I want to prompt it to kind of ask for my own approval before going ahead to book the flight or to book the hotel. So that's the workflow part. So this is the third part of an agent. And then finally, we have the tools. So your tools can actually be anything. In my case, I only have an API connected here, but for example, you can add a browser using browser rendering. You can add internal services, for example, D1. You can add a vector database. Whatever tool you basically want to add here, it's possible. So that's the architecture for the travel planner agents that I've built out. So like I mentioned, Agent SDK is great. It comes powered with every single feature you would need to build your AI agent, including durable object for persistent states, and of course, the MCP server already baked in. So if you'd like to deploy your first MCP server, it's pretty simple to do that using the deploy to Cloudflare button that we have in the docs. But also, if you want to start, it's as simple as running npm install agent within your application. For my specific demo that I shared, I'm using the agent starter kit. This is something I'll recommend you check out if you're interested in building agents on Cloudflare. Pretty much all the features are already set up. You git clone this application and swap out the tools, and you have your agent already deployed. So yeah, I have a few links here that I'll leave with you. If you scan the QR code, it should take you to the agents.cloudflare.com website, where you'd find more resources to help you extend your knowledge in this talk. So thank you so much, and yeah, that's it for me.
Thank you so much.